Hello, I'm Tony Dubio, a Product Solutions Architect for Ansible. Today we're going to look at a demonstration of network compliance and remediation using the Ansible automation platform. With network compliance, oftentimes we need to check a device configuration to determine if it is in compliance with our baseline configurations. So oftentimes that requires us to connect to a device and to check if the configurations deviate from what we think our baseline is, or what we call in Ansible our intended configurations. Moreover, we can also include remediations. So in this demonstration, we will prepare playbooks that we can run against these devices to either add any needed configurations or remove any configurations that are existing on the running configurations of these devices that shouldn't be there. This is a backdrop of what you will see in this network compliance demonstration. First off, I'm going to provide you with a self-service survey so that we can select which protocols and categories of compliance checks we would like to run, as well as which devices or which device groups we would like to run this against in our inventory. For this demonstration, I wanted to make it multi-vendor, so I've included Cisco, Arista, and Juniper devices. Below here we can see that we have a couple bulleted items just to call out some of the mechanics of the underpinnings of how we typically run these compliance checks. First off, we can take advantage of an Ansible feature called check mode. By default, when you run a playbook, it's in run mode. So that means whatever tasks you include in the playbook, it will actually apply those to the targeted device. In check mode, we can run the same playbooks and communicate with the devices and understand what we would need to change, but we don't actually execute those changes on the devices, so it's perfect to run a playbook and glean some information and then work with our change control system to run the actual playbook in run mode at a later time when it's appropriate. Resource modules are something that I wanted to cover too as well, because they're really where the abstractions and the structured data and really the magic of Ansible automation comes to life in terms of making playbooks much easier to interact with these devices, and it gives us a notion of state. So in these compliance checks, I'm running them with the state of replaced, so that way we can take advantage of the iDependency that's included in Ansible, where we can understand what the current state of configurations are, and we can understand when or when not we need to make a change to them, or with replaced, when or when not we need to either make a change in addition, or if we need to remove a configuration that should not be there. If we look to the left, I also wanted to point out in the second part of this demonstration, I wanted to give you a viewpoint of what it looks like to run a STIG role using a compliance check in the Ansible automation platform, which is really easy to implement. And similar types of baseline configuration checks can be ran as well. If you're not familiar with STIG, it stands for the Secure Technical Implementation Guide, and it's a standard configuration for devices as outlined by the Defense Information Systems Agency. And this is an example if you're not, falling under that purview of that particular category. Let's start the demonstration by looking at the project. In this particular project, we will be using a Git repo in this demonstration environment, and we will update our revision every time we launch a job. So every time we launch a playbook, we will pull down the updated content or any other content that's made available, or if it changes as we run these playbooks in the controller. Now let's take a look at our inventory and how we have set it up to support the multi-vendor environment. We have our Cisco group. Depicted here are some group variables and how we connect to Cisco devices specifically. And if we drill into the host, router 1, we can see some host variables that are specific to that particular host with the IP addressing that we use to connect to the management interface. Along that same vein, let's look at the Arista group variables in the host. We have 2 Arista routers, 2 and 4, that we'll use for the demonstration. And lastly, we have our Juniper, which we have 1 router, router 3, for our Juniper host. Now let's take a look at our workflow. In this workflow, we're going to run our network compliance check in check mode. And if it succeeds, we have a green line, which is indicative of moving to the next node or stage in our workflow on success. If that happens, we have a change approval. So this step will actually require somebody to accept the change so that we can subsequently move forward to running our playbook for network compliance in run mode to actually apply those changes to the end devices. But before we start the workflow, let's walk through the playbooks and the roles real quick to set the stage. In the play, we'll use the group variable in our survey to point to whichever vendor we'd like to run the compliance check against. In our playbook task, we're including roles based off of which tag that equals to the type of compliance check you'd like to run or checks. Ultimately, in our handlers, we will track every time and tabulate when a device fails a particular compliance check type. Let's take a look at our role for logging and how it's applied to Cisco IOS. IOS Logging Global is a resource module, so it allows us to read in a configuration through a config parameter. The actual intended configuration is in the roles vars folder, as you see to the left. If anything in the config needs to be replaced, either added or removed, then it will also notify the NTP compliance violation handler that we saw earlier in the playbook. The debug command is so that we can see the standard output on the screen of the built-in diff that's a part of the resource module for logging. The roles vars file is used as our single source of truth to establish our configuration baseline to check against. For iOS, the logging iOS dictionary here is the structured data that we would iterate through to read in as for the variable placeholder for the configuration parameter that was a part of the logging resource module for the iOS that we saw earlier in the role task. And as you can see, Juniper and Arista have similar but slightly different data structures that we read into their resource modules and configuration parameter respectively. Before we run our workflow, let's go ahead and look at this job template. Job templates are how we map to playbooks, and you can see that we would run the first network compliance in check mode. That way it doesn't apply any changes. From here, we'll launch the workflow and populate the self-service survey. For now, we'll just check compliance for logging. Our survey is converted into extra variables. Let's go ahead and launch our workflow, and then we'll examine our job for the workflow, but also for the job template for the compliance check. And as we click into there, we can look on our output and search for the change task. From the change task, let's go ahead and look at our JSON output where we can see the serialized data, the command lines, native command lines that we need to send to that router or remove because we have the state of replaced, right? So we don't actually send or we don't actually implement these commands, but we can see that the built-in diff shows us the before of the existing logging configuration, as well as the after state where it didn't actually change because we haven't applied those changes yet. So we'll go ahead and take a look at the command line here and verify that we have no additional logging configuration that we saw there. It was only check mode at this point. So as we take a look into the existing config, we can verify that. And we can see we just have that one line of logging configuration. Now let's go ahead and take a look at both the Arista and Juniper JSON output respectively. Same thing, we have command lines in the before and after state. And with Juniper, the native is netcomp, so we see this XML payload, and then we can see the structured data for the before and after. Let's take a look at our workflow. And we can see that we are now paused at a change approval stage, which requires us to either approve, deny, or cancel the workflow. So we're going to go ahead and use the button here to approve the workflow. This could be driven from an API or one of our collection integrations like ServiceNow and such as an alternative. And we can see once we approve that, we kick off our network compliance workflow and the network run compliance job template that maps to the exact same playbook, but this time we are running it in run mode, so it will apply the actual changes. So in this example, we will actually remove the unneeded line that we see in our before. Subsequently, in the after, we have the new lines that were added as part of our baseline configuration, or otherwise what we have coined our intended configuration from those variables that we looked at that were a part of the STIG role earlier from the viewpoint of the repo. This time, since our state is replaced and we are in run mode, we will actually add or remove configurations that shouldn't be there. Right there, playbook run, and voila, we have a completed workflow. So let's go ahead and validate that back on router 1. In router 1 here, we'll examine the running config for logging configs, and we can see that we've added these configs and we removed that original one that was in there. Okay, so now that we know what we're doing, let's go ahead and attempt the STIG compliance check, and we'll go ahead and look at one of the configs that will actually come up as part of that check. So we'll see what our timestamp config is currently on router 1, and that would be something of interest in terms of STIG to actually be enabled. Let's repeat our workflow steps again. This time we will select the Cisco devices only and the STIG checks. Our job template starts in check mode. We'll let it run for a second so you can see the STIG rules scroll by. And then we will look at what has changed. Remember, we are in check mode, so this simply tells us in the output that we need to change the service timestamps log date time local time command. Obviously, this command did not change on the router, so we can validate that. Now let's go back and approve our workflow such that we can continue to run our playbook in run mode to make the change. Let's search for what changed, and this time in the JSON output, we will actually make this configuration change to our timestamps, which we validate here. And then ultimately, we culminate into a successful workflow run. Here are some key takeaways that I hope that you noticed in this demonstration. Compliance is required, and since it requires so much level of effort and toil, why not use Ansible to make it much easier? You can utilize check mode in your playbooks to determine what needs to change without actually needing to change it on demand. Secondly, you can use resource modules with the state of replace to allow you to remediate any issues by either adding or removing the necessary configurations. And then lastly, we have handlers in Ansible so we can keep track of which devices are failing compliance, how often, and other information that can help us improve our overall posture. I hope you enjoyed this demonstration, and I look forward to seeing you on the next one.